Machines figuring things out on their own. No instructions, no labels. Sounds wild, right? But here's the thing. It's simpler and more powerful than you think. Today, we're breaking it all down and revealing the magic behind AI's secret weapon. Welcome to Day 17 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're diving into the fascinating world of unsupervised learning. We'll explore what it is, how it works, and why it's such a crucial part of AI. Whether you're new to machine learning or looking to level up, by the end of this video, you'll have a solid understanding of what unsupervised learning is all about. What is unsupervised learning? Unsupervised learning is a type of machine learning where the algorithm learns patterns and structures from data without any explicit labels or supervision. Unlike supervised learning, where the data comes with input-output pairs, like images labeled as cat or dog, unsupervised learning works with unlabeled data. It's all about discovering hidden patterns, relationships, and structures within the data itself. Think of unsupervised learning as a curious child exploring a new environment without any instructions. The child groups similar objects, recognizes patterns, and identifies unique characteristics, all without being explicitly told what's what. Similarly, unsupervised learning algorithms analyze data, cluster similar items, and uncover patterns or anomalies without prior guidance. How does unsupervised learning work? Unsupervised learning relies on algorithms that identify patterns within data. These algorithms try to group, simplify, or describe the data in a meaningful way. Let's break down how it works step by step. 1. Input data. The algorithm takes in raw, unlabeled data. For instance, if you feed the algorithm a set of images, it doesn't know what each image represents. It only sees the underlying data, numbers, pixels, or features. 2. Feature extraction. The algorithm identifies key features in the data. These features could be pixel intensities in images, word frequencies in text, or numerical values in tabular data. Feature extraction is crucial because it helps the algorithm focus on the most informative aspects of the data. 3. Learning patterns. The algorithm uses mathematical models to analyze the relationships between features. For example, it might calculate distances between data points to determine how similar they are. Based on these calculations, the algorithm identifies patterns, groups, or structures within the data. 4th output. The output of unsupervised learning depends on the task. It could be clusters of similar items, a reduced data set with fewer dimensions, or insights about hidden structures in the data. Key techniques in unsupervised learning. Clustering is one of the most popular tasks in unsupervised learning. The goal is to group similar data points together based on their features. Each group or cluster contains items that are more similar to each other than to items in other clusters. 2nd, dimensionality reduction. Dimensionality reduction simplifies data by reducing the number of features while preserving the essential information. This is especially useful when dealing with high-dimensional data, where too many features can make analysis complex and computationally expensive. 3rd, association rule learning. This technique identifies relationships between variables in a dataset. It's commonly used for market basket analysis, where the goal is to discover which items are frequently bought together. 4. Anomaly detection. Anomaly detection focuses on identifying data points that deviate significantly from the norm. These anomalies could indicate errors, fraud, or rare events. Applications of unsupervised learning recommendation systems used to identify patterns in user behavior, enabling personalized recommendations for movies, products, or content. Fraud detection. Anomaly detection algorithms identify unusual patterns in financial transactions, helping to detect fraudulent activities. Healthcare clustering algorithms are used to group patients with similar symptoms or conditions, aiding in diagnosis and treatment planning. That's a wrap on unsupervised learning. It is a cornerstone of AI, helping us uncover hidden structures and insights from unlabeled data. Whether it's clustering, dimensionality reduction, or anomaly detection, the applications are vast and impactful. Ready to dive deeper? In the next video, we'll explore k-means clustering, one of the most popular clustering algorithms. Click on the screen to watch and take your understanding to the next level.